Our next topic, moving into the world of algebra this time, we're going to start with the easiest algebra topics that exist on higher and on foundation. So whichever tier of entry you're doing, these 6 topics will be hugely important for you. First, we're starting with builds on our index laws work we did with numbers, and it will ask us to use the index laws. It may ask us to look at a power of a whole part of an algebraic expression, or it might ask us actually to use fractional powers. So, first things we need to be really clear about, those index laws. Okay, those index laws are things like a to the power m times a to the power n equals a to the power m plus n. It says things like that in revision guides. When you're multiplying, you add the powers. It may say something like this, a to the m divided by a to the n, when you subtract the powers. It may even say something like a to the m all to the power n, where you multiply the powers. Those are the 3 index laws we saw, the simple ones in our index law lesson. And here we are with an algebraic expression, 5x to the 4 y to the 2 multiplied by 3x to the 3 y to the 7. So the first thing we need to do here is deal with the whole numbers. The 5 and the 3 are multiplied to make 15. The x to the 4, x to the 3 are multiplied to make x to the power 7. And then finally, y to the power 2 times y to the power 7 is y to the power 9. That is a nice and simple explanation. Multiply the numbers, deal with the x's, deal with the y's. Nice and simple. Next thing you need to do is to be able to take an expression like 2a to the 5b and raise the whole thing to the power 4. Now this pulls on this index law over here, where you multiply the powers. What you have to be really careful of in this example is every single bit here. The 2 and the a's and the b's all get raised to the power 4. So, that means we have 2 to the power 4, a to the 5 to the 4, and b to the 4. Each of these 3 pieces all get raised to the power 4. Now 2 to the power 4, 2 times 2 times 2 times 2 is 16. A to the 5 to the 4, that's when you multiply those powers, becomes a to the power 20. And this b here, which is the b to the power 1, gets raised to the power 4, becomes b to the power 4. Nice and simple. Same again with this 16p to the 10 all to the half. It's the 16 that get raised to the power a half, and it's the p to the 10 that gets raised to the power a half. Each separate part in the brackets gets raised to that power. So we are talking about 16 to the power a half, p to the 10 to the power a half. Now we know 16 to the power a half, we know that the 2 comes down to be the square root, the 1 goes up to be the power. So we're talking about the square root of 16 to the power 1. Square root of 16 is 4. Now we have p to the 10, p to the half. You multiply those 2 together using this rule we looked at earlier. So 10 times a half is 5. This becomes p to the power 5. Nice and simple. Foundation level and higher, but nice and simple. Next part of this, a couple of more difficult questions to look at for us. We have 18 d to the 8, g to the 10 divided by 6 d to the 2, g to the 5. Now an easier way of writing this that will help you is if you rewrite it instead of using the division sign, use a division bar or a fraction bar. You will find that much easier. This way we can do the 18 divided by the 6. 18 divided by 6 is 3. D to the 8 divided by D to the 2, D to the 6. G to the 10 divided by G to the 5, 10 take away 5 is 5. Nice and simple, especially if you rewrite the division using a fraction bar. And then finally, 64, x 9, y to the 2, all to the negative 1/3. Remember, this power, negative 1/3, is operating on the 64, and on the x to the 9, and on the y squared. It's operating on all three separate parts in the bracket. So we can write it out on each of the three separate parts. It's 64 to the minus 1/3. It's x to the 9 to the minus 1/3. And it's y squared to the minus 1/3. That would get you a mark in a foundation exam paper for writing that. Now we need to work with each of those bits separately. 64 to the negative 1/3. Negative means flip it. It's now 1 over 64 to the 1/3. The denominator comes down to be the root. The numerator goes up to be the power. So we now end up with the cube root of 1 to the power 1 over the cube root of 64 to the power 1, which is equal to 1 over 4. Cube root of 64 is 4. X to the 9 to the minus 1/3, you multiply those two numbers together. 9 times a third is 3, positive times a negative is negative. That's x to the minus 3. The y, you multiply the two powers together. 2 times minus 2/3 is minus 2/3. You can leave your answer as 1/4 x to the minus 3, y to the minus 2/3. That's as far as you would ever go with that level of manipulation. Using your index laws, using them on algebraic expressions such as those. The ones with negative fractional powers would appear on higher. All of the other ones could appear on foundation.